Hello friends, this video on Chemical Kinetics Part 9 is brought to you by examfear.com. No more fear from exam. We have this reaction, and for this reaction we have this rate expression given. It's critical part. And the value of K is given. And you can see the order of reaction is 3, 1 plus 2, 3. Initial concentration of A and B is given. We have to find the rate of reaction after A is reduced to 0.06. Correct? So we have to both find initial rate of reaction and also the rate of reaction after A is reduced. So let's say initial rate of reaction first. So rate is nothing but, let me first write the equation here. 2A plus B is equal to A to B. So at T is equal to 0, A was my 0.1 m, B is 0.2 m moles per liter, and at T is equal to, after some time T, A will be reduced to 0.06 m, B we don't know, right? So initial rate nothing but K, same value will put here, concentration of A, concentration of B to the power 2. So since it is initial rate, we'll put all the initial values. K, value of K is given 2 into 10 to the power minus 6. Unit will just put like this. Concentration of A is given 0.1 mole per liter, and concentration of B is given 0.2 mole per liter. B has to be squared, so put the square. Please note there is a square here. Correct? So if you solve this, you get 8 into 10 to the power 9 moles per liter per second, and that is my answer. And if you see, the rate is always in moles per liter per second. If you see this units also, end of the day you will get moles per liter per second. Now the question is, what is the rate after A is reduced to 0.06? So final rate, again same equation will use, K A B to the power 2, but here concentration of A and concentration of B, final concentration we have to use. So K value is same, 2 into 10 to the power minus 6, not writing units because end of the day it will come out to be moles per liter per second. Concentration of A is given 0.06, concentration of B square. But what is the concentration of B? Final concentration we don't know. Correct? So let's find that. So if it is 0.1 m, it is 0.2 m, and let's assume this become 0.1 m minus 2x. So this will become what? 0.2 m minus x, because this is 2A. So 2 moles of A is consumed, and then 1 mole of B will be consumed. So with this logic, 0.1 m minus 2x is equal to 0.06. Correct? So with this, if we solve the value of x, x will be nothing but 0.02. If x is 0.02, the concentration of B is what? 0.2 minus x, that is 0.02. And that is nothing but 0.18 m. That is the concentration of B. Hope you understand this. See, 0.1 m minus 2x. This is the concentration after some time t. If there is a concentration of A, concentration of B will be 0.2 m minus x. As 0.1 m minus 2x, that is the concentration of A is given 0.06 m. You solve this, x becomes 0.02 moles per liter. Right? So if x becomes 0.02 m, if you put this in this equation, 0.2 m minus 0.02 m, that is nothing but concentration of B at T is equal to T. That comes out to be 1.18 m. This becomes 0.18 to the power 2. And it will be, unit will be moles per liter per second. Correct? Now if you solve this, you put all the values, you solve this, what you get is 3.89 into 10 to the power, it will be in 10 to the power 9 minus 9 moles per liter per second, and that will be the answer. Okay. So if you see here, the rate of reaction has decreased from 8 into 10 to the power minus 9 to 3.89 into 10 to the power minus 9. Right? As the time passes by, as the concentration of reactant goes down, the rate of reaction also will decrease. So the question says the decomposition of NH3 on platinum surface is zero order reaction. Let's write the reaction first. NH3 decompose into N2 and H2. Let's write a balance order reaction in presence of platinum catalyst. And it says the rate is nothing but zero order reaction. That means NH3 to the power 0. Correct. What is the rate of production of N2NH2? We know that rate we can easily find because this is nothing but K. This becomes 1 and K is given. The rate is nothing but, if you see, minus 1 by 2 change of concentration of NH3 by change in time, or change of concentration of N2 by change in time, or 1 by 3 change of concentration of H2 by change in time. You know this, and this is nothing but rate, that is K here. What we have to find? We have to find the rates of production of this. So this is nothing but K, and that is nothing but given 2.5 into 10 to the power minus 4 moles per liter. This is zero order, right? It will be moles per liter per second. There's something wrong in this question here. It's moles per liter per second. Right? Similarly, if you want to find the rate of production of H2, that will become 3K. Right? 3K. And that is nothing but 3 into 2.5 into 10 to the power minus 4 moles per liter per second. And that is nothing but 7.5 into 10 to the power minus 4 moles per liter per second. Pretty easy. See, rate is given. It is given that it is zero order reaction, so I can easily find the value of rate. It is nothing but K. And rate is nothing but change of concentration of N2, or 1 by 3 of change of concentration of H2. Right? So I have to find the rates of production of N2, that is nothing but K, and rate of production of H2 is nothing but 3K. See, this question looks big but pretty easy actually. The decomposition of dimethyl ether leads to the formation of methane, hydrogen, carbon monoxide, and the reaction rate is given by this. And this reaction is followed by increase in pressure in the closed vessel. So rate can also be expressed in the terms of partial pressure. Everything is in the gas form, everything in gas and the closed vessel. So everything I can write in the terms of partial pressure instead of molarity. And rate, again, the rate law is given. If the pressure is measured in bar and time in minutes, we have to find the units of rate and rate constant. See, rate is given. So rate unit is always either in moles per liter per second or bar per minute. Why? Because rate is nothing but concentration per unit time. So concentration here is in bar and time is in minutes. So unit of rate is bar per minute. Bit easy. The next is unit of K. So K is nothing but, if you see, rate by CH3O CH3 to the power 3 by 2. What is the unit of rate? We have seen is nothing but bar per minute. What is the unit of CH3 or CH3 concentration? That is nothing but bar, and this is to the power 3 by 2. So if you solve this, it's nothing but bar to the power minus 1 by 2, minute to the power minus 1, and that is the unit of K. Pretty easy. See, now this concentration is measured in terms of partial pressure, and partial pressure is measured in terms of bar. Let's take another example. A reaction is second order with respect to a reactant. This is a second order reaction. How is the rate affected if the concentration is doubled and reduced to half? So that means I have a rate is nothing but K times some reactant to the power 2. That is my example. Reactant to product is my equation. This is my rate law. Now, so in case of one, let's suppose first scenario, my concentration was X. So this was my rate. Second scenario, my rate concentration becomes 2x. See, this is from X you make it 2x. Correct. So first case rate becomes K into X square. Second case rate becomes K into 2x square. There is nothing but 4 into Kx square, and there is nothing but 4 into R1. If you see, R2 is nothing but 4R1. So if I double the concentration of reactant, my rate is 4 times. Similarly, same thing, reduce to half. You reduce the reactant concentration by half, the rate of the reaction will be 1 by 4th. This is X. Let's suppose this is the third scenario. So instead of X, I'll make it X by 2 square. This is, if you see, 1 by 4 Kx square, and there is nothing but, if you see, 1 by 4 R1. So if you compare, R3 is nothing but 1 by 4 R1. The second scenario is R3 is R2, and my normal scenario is R1. So if you see, if you double the concentration of reactant for a second order equation, second order reaction, actually the rate is 4 times. If you halve the concentration of reactant for a second order reaction, the whole rate is 1 by 4 times.
Thank you. Visit examfear.com to watch more videos, attempt free online tests, get free study materials, find tutors and mentors, and much more. Thanks once again.